Hi, this is Mrs. Doris. This is lesson 9-4 entitled Factoring to Solve Quadratic Equations. Our objective in this lesson is that you will factor quadratic equations by factoring, and then we're going to use the zero product property in order to solve the equations or find the roots of the equation. This will take us back to chapter 8 where we were factoring trinomials. Some quadratic equations can be solved by factoring using the zero product property. Now note, the word some means that not all of the quadratic equations can be factored. And in our upcoming lessons we will have other methods that we can deal with those. But using the zero product property, what that property says is that for any real numbers a and b, if you multiply a and b together and get 0, then either a has to be equal to 0 or b has to be equal to 0. And here are some examples. If we took a times 0, we get 0. If we took 0 times b, we would get 0. Using numbers in our examples, 4 times 0 would be 0, or 0 times 5 would be 0. Alright, so first of all, we're going to begin just by using the zero product property. What are the solutions of each equation? What we have here are two binomials multiplied together, and we get 0. So what this tells us is either x plus 1 has to be equal to 0 or x minus 5 has to be equal to 0. And so we simply solve each equation. Subtracting 1 from each side, I get x equals negative 1. On my other equation, if I add 5 to each side, I get x equals 5. So I have two solutions here, negative 1 and positive 5. And if we were to graph this quadratic equation, you would find that the parabola will intersect the x-axis at negative 1 and positive 5. All right, let's go to the next problem. Once again, two factors. We're going to set each one equal to 0. So either 2x plus 3 equals 0 or x minus 4 equals 0. So in our first equation, we're going to subtract the 3 first from each side. That gives us 2x equals negative 3. And then dividing by 2, we get x equals negative 3 over 2. And you can leave your answer in that form. On my second equation, x minus 4 equals 0, we're going to add 4 to both sides. That gives us x equals 4. So our two solutions are negative 3 over 2 and 4. And again, if we were going to graph this equation, we would find the parabola intersecting the x-axis at negative 1.5 and also at positive 4. All right, we have a couple more. Again, it's just a matter of setting each one equal to 0 and solving the two equations. All right, subtracting 1 from each side, we get 2y equals negative 1. Dividing by 2, we get y equals negative 1/2. On our other equation, we subtract 14 from each side. We get y equals negative 14, so our two answers are negative 1/2 and negative 14. All right, second equation here, either 7n minus 2 will equal 0 or 5n minus 4 will equal 0. In my first equation, if I add 2 to both sides, I end up with 7n equals 2. Divide by 7, and I get n equals 2/7. On my second equation, I would add 4 to each side. That gives me 5n equals 4. Divide both sides by 5, and I get n equals 4/5. So I have two answers here, 2/7 and 4/5. And again, these would be the roots of the equation. They would be the x-intercepts of the graph, and they're also known as the zeros of the function. All right, problem 2. Now we're going to do the factoring. This takes us back to chapter 8, where we were factoring trinomials, and these are all quadratic equations. So if you remember, we drew two sets of parentheses. Our first term is going to be m, because when we multiply m times m, we get m squared. Then we're looking for the factors of negative 14 that add up to negative 5. And those numbers would be negative 7 and positive 2. And remember, you can verify this by using FOIL. All right, then we do exactly what we did in problem 1. We set each one equal to 0. And as you practice this and get good at this, you can probably solve these without showing all the work. But in this video, I am going to show the work. Be aware, if you get the wrong sign, it will be incorrect. So here we get m equals 7. Subtracting 2 from each side over here, we get m equals negative 2. So our two answers, negative 2 and positive 7. All right, p squared plus p minus 20 equals 0. When we factor this, our first term is p in each set of parentheses, and we're looking for factors of negative 20 that add up to a positive 1. And that would be positive 5 and negative 4. So setting each factor equal to 0. All right, and on our first equation, subtracting 5 from each side, we get p equals negative 5. In our second equation, adding 4 to each side, we get p equals 4. So our two solutions, negative 5 and positive 4. And that should be p equals. And let me get rid of the parentheses. That looks like a point. All right, so p equals negative 5 and positive 4. All right, one more. This one is, remember, a little bit more difficult because our a is not equal to 1. So we have to take our a times our c. 2 times 18 would be 36. And we want factors of 36 that add up to negative 15. Those two factors would be negative 12 and negative 3. All right, negative 12 times negative 3 is positive 36, and when we add them together, we get negative 15. So now I'm going to rewrite my equation. Rather than the minus 15a in the middle, I'm going to replace it with negative 12a and plus a negative 3a, because we know that this right here will equal negative 15a. All right, now we're going to group them. I'm going to group the first two together, and I'm going to group the second two terms together. My greatest common factor in this first set is 2a. So factoring out 2a, I'm left with A minus 6. All right, and again, check yourself at this point to make sure if I use the distributive property here, do I get the original? And I do. 2a times a is 2a squared, and 2a times minus 6 gives me the minus 12a. All right, let's do the second group. I'm going to take out here negative 3. 3 goes into 3 and also into 18, and so I'm going to remove that negative with this 3. All right, so remaining I would have a, and negative 3 times a negative 6 would give me this positive 18. All right, so now I'm ready to write my two factors. The first one is in green. It's the same in both sets of parentheses, and so I'm going to factor that out, a minus 6. My second factor is what is in red, the 2a minus 3. And again, if you FOIL this, this is a good time to check yourself to make sure you have the correct factors. You should get our original quadratic equation. Okay, so let's set each one equal to 0. A minus 6 equals 0. Adding 6 to each side, we get a equals 6. And in our second equation, taking 2a minus 3 equal to 0, we'll add 3 first to get 2a equals 3, and then divide by 2 so that we get a equals 3 halves. All right, so my two solutions are 3 halves and 6. And you might ask, is it incorrect to say that 3 halves is 1.5? And no, that would be fine. Either way. All right, problem 3. Writing in standard form first. What are the solutions of x squared plus 14x equals negative 49? All right, I'm going to write my equation again over here. And here's what I notice that's different about this one from the others. Right here, I have a number that is not 0. So what I want to do is I want to change this so that I do have 0 on the right side of my equation. So to get 0, I'm going to have to add 49. And I'm going to have to do that to both sides so that on the right side of my equation, I get 0. Now, you'll notice on the left, we can't combine, we don't have any like terms, so we simply write it out, x squared plus 14x plus 49. All right, we want to factor this. X is our first term in each set of parentheses. Factors of 49 that add up to 14 would be 7 times 7. So here we have two factors that are the same. In fact, we could write this as x plus 7 quantity squared equals 0. So what we note here is we really have only one factor that we have to solve. X plus 7 equals 0. Subtract 7 from each side, and we get x is equal to negative 7. And that is our only solution. So what this tells me is the vertex is on the x-axis at negative 7. Okay, problem 4. Using factoring to solve a real-world problem. You are constructing a frame for a rectangular photo that is 11 by 17. You want the frame to be the same width all the way around and the total area of the frame and the photo to be 391 square inches. What should the outer dimensions of the frame be? All right, I'm going to redraw my little picture. I have a frame that I want to put around a picture, and the picture is 11 going this way, and 17. All right. Plus I want to put a frame the same width all the way around. So I'm going to call my width X, and it's going to be X on all sides. All right. Plus, I want the total area of the frame to be 391 square inches. So, what I notice is that my entire width from here to here is going to be the 11, okay, plus the x and plus the x. So in other words, x plus x is 2x plus 11. All right. My vertical distance from edge to edge is going to be x plus the 17 plus another x. So again, 2x plus 17. Now, what happens then is when I multiply my length and my width together, I want to get 391 square inches. All right, so we are going to FOIL this, and then we're going to have to make this right side equal to 0. So this is going to involve several steps. Okay, multiplying 2x times 2x, we get 4x squared. 2x times 11 is 22x. 17 times 2x is 34x. And 17 times 11 is 187. And that's all equal to 391. Now we want to subtract 391 from each side to make that equal to 0. And then we're going to factor this again. Okay, so here we go. I know I have 0 on the right side. That's what I want. I have 4x squared. Let's combine these two terms. They are like terms. And that 22x plus 34x would be 56x. And a positive 187 minus 391 would be a negative 204. All right, now we're ready to factor this quadratic equation, and what I notice is that 4 will go evenly into all three of these. So I'm going to factor out my 4, and that will make my factoring so much easier. 4 times x squared is 4x squared. 4 times 14 will give me 56x. And 4 times negative 51 will give me the minus 204. All right, so here we are. We're ready to factor this trinomial. Factors of 51, negative 51, that add up to 14 would be a positive 17 and a negative 3. Setting each of these factors, I'm going to move over here to the left. X plus 17 equal to 0, and subtracting 17 from each side, we get x equals negative 17. And, all right, maybe I should say or, x minus 3 has to be equal to 0 to find our x-intercepts and our solutions. And adding 3 to each side, we get x equals 3. So our two solutions are negative 17 and 3. All right, that concludes our lesson. For your homework, I would like for you to work on the 9-4 lesson check. If you have any questions, please bring them to class. Thank you very much.